Kia ora koutou. I'm here with Yolanda Vogel, who is an archaeologist and a faunal analyst. Yolanda, can you tell us a bit about the type of analysis you do and what kinds of information and interpretations do they provide?
Hi, Patricia. Yeah, sure. So I work with animal remains from archaeological sites. So other archaeologists send me samples of midden from the sites that they're working on, because most people don't want to sort midden. And I sort those into their constituent parts, so shellfish, fish, bird, mammal, and mammal depends on your time frame, can be, with pre-European sites, it's rat, dog. I very rarely get seal, but, depends where in the country my sample's from. So my home patch, I don't get seal, but if someone from Auckland was sending me something, I might have some of that sort of thing in. Send me samples, I sort them into their different components. Then I identify each thing to species, so different species of shellfish, different species of fish, different species of bird, etc., using reference collections. And then I can answer questions about people's previous lifeways, how people were interacting with the environment, what sort of food they were eating, how they might have been collecting that food, all that sort of thing.
Wow, that's really awesome. And that leads in quite nicely to our second question, which is what types of equipment do you use and why are they important?
So I have a whole range of things that seem really mundane, but are actually exceedingly important to my life. So the first thing is my sieves. My preference is for people to send me their samples as what we call bulk samples. So they've still got the soil or sand or whatever the archaeological site is in around it. And that can be quite helpful for me for working out why the shell might be in the condition it is, seeing other things that might have happened, so like if it's in a sandy matrix but it's quite dark and greasy, I know that that's been burnt, things like that. I can get an idea of that sort of thing from. I also use different size meshes so that I can sort my material in different grades. So I get rid of all the big whole, beautifully preserved, nice whole shells first. If you're lucky, most of your assemblage is like this. And then I slowly work down to more and more sort of, I don't know if you can, these are tiny little bits, more and more fragmented as you go, little bits of stuff. And for the tiniest, this is still drying, freshly washed this morning. I don't know if you can see, it's all slid away.
Fantastic.
That's from my smallest sieve, which is a 2 millimetre sieve. The next one up is a 5 millimetre sieve. So all that stuff is between 2 and 5 millimetres in size. And there is a lot of bone in there. And that's where most of your bone will end up. And also little broken diagnostic portions of shellfish as well will end up in there. Next important things are trays. They seem really boring, but trays. I have trays and trays and trays of varying sizes. So I have a big tray that all my material is on to start with that I work through very methodically. You bring a little bit forward at a time, go through it, sort out the bits you are looking for, and put it into the smaller trays around you. So I'm currently surrounded by trays of different shellfish, bits of fish, some charcoal, some seeds. Because I also, as well as sorting out the animal stuff, I need to keep an eye out for things for other specialists. So that was a Miro seed, and from the Miro tree, but it's actually has a fruit around it, like a berry fruit that was edible. So that is actually food, probably. So my tweezers are the next important thing, because a lot of these things are very small and I'm packing them up with tweezers. Obviously, the bigger shell I hand sort, but once I'm down to the smaller, the 5 mil sieve and the 2 millimetre sieve, I am using my tweezers for everything. Next really important thing is everything has to be counted. You don't want to be doing that in your head. So I have my tally counter, and I count all the material so that I can tell what proportions of different species are present in the site, which helps me look at, what is the most popular environment that people are exploiting, different things like that. And I also weigh everything. So I have precision scales. I have bigger scales to weigh the sample at the start, so I know what I started with. And then everything gets weighed on my precision scales that weigh to like 2 decimal places, because often my fish bone, I will have less than a gram of something. So I need to be really precise with my weights. What else for? I have a magnifier lamp, which is out of shot, but it is, once I'm down to that 2 millimeter stuff, I am working with my magnifier lamp. I'm looking through basically a big magnifying glass, because no, my eyesight isn't that good. I don't think anyone's eyesight is good enough to see all those tiny things. And it's really important to get all that stuff, because if you're missing, well, for a start, all your small bone is in there, so you want to be collecting that, because obviously that's telling you something about what people were eating, but also your really small pieces of diagnostic shell. You can end up skewing your sample massively if you've got a sample that, some of your shell, one of your shell species may be really highly fragmented, maybe quite susceptible to fragmentation, and end up in that very small sample, and you could end up missing a lot of it and throw out your interpretation by quite a lot. So it's really important to get all those little pieces. And then the next really important thing is reference collections. I have, look, here I have some reference shells. There's some nice, I live not far from the beach that my main projects have been a local the last several years. I do work nationwide, but the recent ones have been local, and I have such a ridiculous number of shells from that beach. So reference collections are really important. I also have a large rocky shore shellfish collection from when I lived in Wellington. I made use of the rocky shore down there, because quite often you can have species that may look quite similar and they are not. So that's a tohara. And people hear tohara and they think, oh yeah, it's really big, you'll be able to tell that. And it's like, yeah, no. So tuatua, tohara, cousins, closely related, not the same thing. And I often get small amounts of tohara in my samples, so I need to be able to spot those and recognise the differences. So sometimes, like now I can do it by sight, I just know. But sometimes, particularly for things that aren't as common, you need to be looking at your reference samples, reference specimens to check what it is. For bird and for fish, it is even more important to use a reference collection. Books can be helpful as an initial start, but they're just not a substitute for the real thing. And I'm really lucky that I have access to Te Papa, which has, like a world-class, reference collection for their natural history bird collection is just amazing. And you also really need to be using a microscope to identify bird bone. Like they can look quite similar. You can be looking at, a reference bird bone and your archaeological one and going, oh yeah, they look the same. And I've done this many times at Te Papa, going, yeah, they look the same. And then I stick them under the microscope and go, nope, Xbox. So those reference collections are really, really important to be using. So yeah, I think that's it for equipment that I can think of. I'm looking around and there's sort of like not much. And as I say, a lot of it's like really sort of mundane things, like, literally plastic bottles that I bought at Moore Wilson's to use as sorting trays. But they're so important.
And I think you've actually touched on this a little bit, but how do you approach and handle highly fragmented material?
So essentially, actually, really exactly the same. So that's where my my nested sieves with their different mesh sizes really come into play, because I'm sorting out any big stuff to start with, and then I can really focus on the more fragmented stuff. But sometimes you get samples where just the whole thing is fragmented, like it will all go through my 9.5 millimeter sieve, or most of it will, and then you kind of cry, and then you suck it up and you just do it, because I think a bit like if you're doing jigsaw puzzles. So you've got a nice 1,000-piece jigsaw puzzle, and it's this dimension, and then you've got a 5,000-piece jigsaw puzzle, and it's the same dimension, so same sample size. But they're two different pictures. If you only do half of your 5,000-piece puzzle, you're not going to get the full picture. So you really need to actually just suck it up and work through it really slowly, really methodically, slowly but as fast as you can, but you've got to be really careful when you're doing it. It just takes longer, but it has to be done. It's no less, a fragmented sample is no less valuable than a nicely preserved sample. And in fact, sometimes it gives you more information than your nicely preserved sample, because you've got to think about things about why is the sample so fragmented? And that may tell you about other activities that are going on at the site. So it's quite important to just work through those samples and not disregard them. And some people do just go, oh, I'm not going to sample that site because it's really fragmented. And I think that is very wrong.
Thank you so much, Yolanda. You've just shared with us the incredible knowledge you have, and how much work actually goes into the analysis that you do, and why it's really important to consult a specialist in their field as well. So thank you so much for that.